Welcome to Tell Me More, Coffee with Chris Yip, the official podcast of the Faculty of Applied Science and Engineering at the University of Toronto. Each month, I sit down with someone from our vibrant global community to talk about what places them at the heart of designing bold solutions for a better world. You'll meet alumni, students, and professors who are making a difference across a range of fields, including some where you may not expect to find them. My guest today is Jenya Doudareva, a triple graduate of U of T Engineering who completed her PhD in 2021. Today, Jenya uses her background in industrial engineering in cloud and AI consulting at OnX, where she helps businesses find effective and ethical ways to deploy AI. Jenya, welcome to the podcast.
Thank you so much. It's absolutely lovely to be here today.
To be back on campus.
I took a really long walk this morning all over the campus, and I had butterflies. It was great.
We're recording this probably the last 2 weeks of classes. You're thinking butterflies of exam season coming up, and you're thinking,
That's right. But the great thing about some time passing between degrees is kind of all of the exam anxiety smoothes over, and you just remember all of the beautiful moments.
So we'll have to remind all our students and all the prospective students, yes, it does get better, and all things ease over with time. So we were talking earlier in the intro to this a little bit about industrial engineering, and I remember when I went through my undergrad degree, I had friends from first year that were in IndE and trying to think, man, I know what chem is, I know what electrical is, but what is IndE, right? And so I'm going to start maybe with that. Is sort of like you did all three degrees, so you clearly sort of landed in your niche early. Maybe give for our listeners a little bit of a sense in your mind, what is IndE about?
Yeah, and I think I'll start a little bit with why I was drawn to IndE. As a child and throughout my whole life, one theme is I like variety of subjects. I am a little bit of a jack of all trades, hopefully master of some. And as a result, I've had a lot of curiosity about a number of science topics. I liked math, I liked physics, all of the above. So when time came to select my program, first of all, I thought, one, engineering is going to be just the best bet for me. And secondly, I wasn't quite sure exactly which engineering I should go for. However, when I read the description of what IndE at U of T specifically offered, I was very excited by the fact that, one, there were multiple streams that you could specialize in, and that it was also a little bit fluid and thus, to me, adaptable to the future. When I was doing my undergrad, so I started in 2006, then there was the financial crisis. So a lot of, I would say, complexity in the world began. So I really thought that a program that can allow me to be nimble and flexible and pick what I want to apply myself in afterwards would be really good for me. And to me, IndE is exactly that. So it's an opportunity for students to get really, really, really great skills in a number of things. So I know that a lot of people are very attracted to stricter specializations, and I think the industrial engineering is the opposite of that. And not to say that it's just a catch-all that does whatever. No, it's quite structured, but the goal of IndE is to use your engineering mindset to solve problems, to be like an actual real engineer, and to me that was incredibly attractive. So obviously I was really, really happy with my choice.
No, it sounds great. And that's actually something that interestingly I think drives a lot of conversation around IndE. It really is a systems program, right? You're thinking about systems sort of holistically rather than I'm dealing with a chemical process or I'm dealing with a civil process or I'm dealing with an electrical circuit, right? We're going to go through your career because you've done a whole bunch of different things. But I think that's, to me, is what's fascinating about it is you've got this ability you learn this ability to integrate stuff from all the different disciplines together. So you really are a systems integrator.
Absolutely. And it allows you to take a step back and to have a really good view of what tools are good for what task and what's the broader, bigger picture of the work that you're doing for people. And exactly, it's the systems thinking that ties it all together. All of the turns that my career has taken, I would very much credit the foundation that industrial engineering has set for me in being able to pivot and be nimble and kind of go with where I think I can apply myself better in kind of like in the next chapter.
if I was to sort of say, oh, Jenya did 3 degrees in industrial, people may go, well, so that meant she started when, you're 17 coming into undergrad in 3 degrees. So you got your undergrad, which is 4 or 5 years. You've got a master's, which is 2. You got a PhD. So you figure, okay, this is a linear path. And then finally, you decided to leave the ivory tower. But in fact, you actually spent time in industry before cycling back, right?
I did.
And in different sectors.
Yeah, I like to think that way. In the end of the day, it ended up being a little bit organic. So I was doing my undergrad where I got to working closely with Lady Dion Aliman, and she took me on as an undergraduate researcher to her lab, and I absolutely loved it. That was the first time I thought research and a lot of focus in OR was incredibly cool. And so at the time, we ended up publishing a paper out of the research that I did. So it was all about skeletonization algorithm for Gamma knife. So it's finding perfect isocenters in brain tumors to irradiate. It was really incredible to learn from her. And as a result, it really informed me into going ahead and doing my master's right away. So then I worked with Mike Carter very closely, did a lot of research, less so in directly medical, and more so in more healthcare as a system. And I quite enjoyed it. So at that phase, as I finished my master's, I thought, all right, it's time for me to actually, I feel ready to use my skills in the industry. And I did spend some time in healthcare settings. And at the time, I didn't really feel that it was a perfect fit for me. So very easily, I decided, let me actually pivot. I very briefly worked also in aviation sector. The job was more optimization focused, but ultimately just not a great place for me. And I ended up then going into consulting. And obviously, so that path has stayed on and off for me throughout so far my adult life. I love it because consulting is also systems thinking. And I would say from what I know, a lot of industrials engineers do end up in various specializations of consulting for that same reason, because we are able to abstract problems, apply the right tools, optimize where needed. And nevertheless, so after working in consulting for some time, I missed engineering. I missed U of T absolutely incredibly. And as I was chatting with Mike Carter on one topic or another, I thought, okay, how about I think it is time to go back and do my PhD and actually do more comprehensive amount of research. So I ended up doing that again afterwards back into the industry. So I think I have an ongoing and evolving relationship both with U of T, IndE, and academia, as well as professional environments. And I really don't like to view them as completely separate. I think it's always kind of in conversation between one another where my skills need honing, what do I see kind of responding to the need I see in the industry, et cetera. So who knows, maybe I'll go and do another PhD at U of T.
Well, I was going to say, we encourage or there are opportunities to do like an industrial postdoc. Or, so you bring a postdoc back into the academic sector where they're tied to industry. So you could there's no time limit. So
that's exactly
we could actually bring you back in and bring you in as a postdoc. We do get a lot of people bridging into it, right? And I think one of the things I love is when alums in particular come back and they contribute often by being a sessional, or in your case, as giving a seminar in a course, right? And I think this was an MIE course, right? 191. So maybe give us a little bit of a sense of what that was like. What did it feel like getting asked to come back, and what was the reception? What was the topic?
Yeah, it was really great. So that particular seminar was, I would say, similar. The similarity to today's podcast, it was me giving my experience as a alumna of U of T engineering to give a bit of a showcase, a sampler of where I am today, what types of problems I'm solving, and how does that tie with my industrial engineering career. So at the time I was with a different organization. So I was in insurance space, and it was already also with AI. So I gave some of the examples of the type of work that we do, how an industrial engineer really can fit into that profession, answered student questions. And I did have students reach out afterwards on LinkedIn as well with so many good questions. How do we get in? Do we have to take XYZ course? What happens when AI takes all of our jobs? So many really great and important topics. So it felt incredible to come back. And I believe that mentorship is one of the most important things you can do, especially as you mature. I think you have a responsibility to the younger generations to really help them. What this reminded me of is being a first-year IndE student myself. And even though I was confident that this was the right program, you aren't sure what exactly to do. The world around you just keeps changing all the time. And I think it's even more the case today. I think students can feel very overwhelmed with what does that mean 4 years down the line when I'm done my degree? Will I have made the right choice? So yeah, I think it's incredibly great to be that person on the other side that says, hey, you're doing great. Don't worry too much whether the specific coursework is exactly what you think you will need to be doing in your job. You will figure this out, because what engineering at U of T teaches you is groundwork on how to think and how to be an engineer and how to contribute, and everything else. Brilliant kids, all of them, they will pick it up.
The projects you did, the stuff you did with Mike and obviously the late John Allman, I think that really shows that impact, right? Because you've got technical stuff, but it's in that sort of healthcare space, in the medical space, right?
Absolutely. I really loved it. I think what all of those projects taught me is that you can take a very intentional, very academic way to solving a problem, and you can really contribute in a real setting. So I like that bridging of the gap always. And I fell in love in just being able to be there for an industry, help them structure their thinking perhaps in a way that they haven't seen before or isn't typical of them. Because I would say in healthcare, who is healthcare full of? Of course, healthcare practitioners. They're not necessarily systems thinkers. A lot of them are very specialized in what they do. They're excellent and brilliant. However, there is a lot of value in an engineer and the particular way in which we attack a problem, break it down into little pieces and optimize it, that's so incredibly valuable. I think on reflection, when I was younger still, I think I fell a little bit into the trap of thinking, okay, well, I did my research in healthcare, therefore, does that mean I need to work in healthcare? But as I matured as well, and gained confidence, I really started seeing that, oh no, not that it's rinse and repeat, all industries are different, but rather I have the confidence to learn what I need to learn and to apply myself. And I think, again, that was a great part of industrial engineering, because we focused so broadly, and we were always trained to think, all right, now you're in a chemical environment, now you're in software engineering, you're doing this. And that ability to pivot was incredible. And even all of the things that I remember as an undergrad, I found so painful. At the time, initially, I hated coding. It was just the worst thing. Yeah. But as I matured, I'm like, all right, well, I actually need to be able to do this in order to run optimization models. I actually need to now teach myself Python, because after just a couple of years, Java is no longer as relevant. And initially, that complexity is so frustrating. But then you realize that you have all of the tools to teach yourself. And how do you get them? You get them through the programs that you take.
When you think healthcare and engineering, the stereotype you drop is this sort of biomed, right? You start thinking drug delivery and that kind of stuff. But then you realize, healthcare, delivery of healthcare is a systems problem, and delivery of efficient, and we're going to say economic, sustainable healthcare actually requires a very broad perspective on what it means. That's all engineering. That's 100%. All industrial engineering.
And human factors as well. Always that layer of how are you interacting with people? Can you understand how they're making decisions? How does that factor into the solutions that you're going to provide them as well? This actually really ties with master's work that I did with Mike Carter. We were working with Sunnybrook Health Science Center, and specifically their emergency department. And we were looking at what is a good amount of notifications that a physician should have throughout the patient stay? Are you tuning it out? Is it actually going to be meaningful to you to get yet another notification about a status? Can you make a decision based on that? So it's really, when you dig into it, the number of problems you can solve is just mind-blowing.
In this age of data overload, right, and just massive amounts of information being both generated, collected, I think is the other way to look at it. And IndE is such a data-rich field. You know, it really is kind of the home of sort of the application of AI now, right? You talked about coding in different languages. You're now in that space, right, where you're working with industries that are both deploying, coming up with new ideas and strategies. And can you give us a sense of what that feels like right now?
Yeah, of course. So one, AI is a very, very hot field right now. It has been for a couple of years. And I think the speed of its progress across industries is only increasing, as I would say how polarizing it can be. What it feels like in the space right now is there are a lot of opportunities, a lot of incredibly powerful technologies, but in a lot of cases, a lack of structured knowledge of how to best apply them. So really, really rich with potential tools that can solve problems in ways in which we couldn't solve before. But with that comes a lot of potential danger. So to me, what's incredibly important is to guide organizations, people in general, on how to do that right and how to use this technology for good rather than for evil. So that's what I'm doing.
Classic tone. Yeah.
Absolutely classic one. That's what I'm hoping to achieve right now through the work that I'm doing. I will also say, so with AI, and I can very much put myself into a mind set of a student, that you might think that it is about the data sets. It's about the model itself, the algorithms that are underlying, how you're training, how you're monitoring. And that is a very, very important and valid part of it. But again, as we've been talking about systems thinking, it's about the system over it. AI is not just a tool. It is also governance, it's people, it's strategy, it's how you're using it. So it is much more rich and complex. So therefore, there are quite a lot of areas around it that do need support from engineers, from anyone who kind of has that very strong systems thinking.
Can you give us some examples where, from your experience across your breadth of different opportunities, examples where you think industry has done a really good job at deploying it and using it, and cases where they thought it would have worked, but it didn't? And sort of, how things were caught.
Of course. I think to me, so a good deployment of AI needs to needs to satisfy a few criteria. One, you have to have a really strongly defined problem of what it is that you're trying to solve. And therefore, right after that, what specific AI tool are you picking to solve that problem? So does it specifically act in its interest, or are you simply throwing a tool and hoping that it will meet your needs? I think to me that is the crux that really separates good versus bad. I think some of the best examples I can think of off the top of my head would be very specific use cases, let's say in medical fields. So analysis of medical images, where you're very intentional with first of all, what problem are you trying to solve? You're trying to more accurately analyze and identify particular objects, so clearly well-defined problem. And then based on that, you select very specific models that are going to be excellent at it. You then take it the next step. You have the right training data. You train them, you implement them, you test how well that works. So really cleanly defined. And of course, an underlying aspect of it, can you do so repeatedly and from a perspective of a system? So not just one person on one-off occasion is able to do it, but does this actually benefit your entire medical facility? Can people interact with this technology well? How are these then outputs and decisions being taken forward? So to me, that's a really good implementation AI. The not so good ones are the ones where you didn't really quite start with a clear problem. Perhaps you heard some hype that AI can really increase productivity. It doesn't need to have too many of the pesky headcounts, and you just think that kind of a general purpose model will solve your needs. And I think not to call out any individual organizations, but we've seen that on the news enough, right? That organization decides to replace all of its agents with AI, and then suddenly there is a huge blowback from the customers and everything. And why is that? Is because there is a simply not well thought out of the implications if you now don't have these agents, what AI can and cannot do for you. And so, yeah, all of it always rolls back to, did you define your problem well, and did you select the right approach for it?
The other one, obviously, in the generative space is sort of using it as a tool to help, make your life more efficient and parse stuff so that you can come up with summaries quicker and so on. And I worry that you lose the human voice, in a sense, like your personal voice. When people use a generative system, it loses authenticity at some point.
100%. And so I myself, I'm hoping to be a science fiction author.
I know you are, because I looked it up. You have a book that's out on Amazon.
That's right.
Right?
That's right, I do. So that was a book of poetry.
Yes.
I'm writing science fiction stories, etc. But the way that I as a writer, though, I can see sort of the negative aspect of generative AI. Everything is smoothed over, kind of a very polished. Well, that's what happens when you take a lot of averages and you generate text. Nothing wrong with that, but I think it's also, I would be careful as a student, perhaps as a person as well, to replace my own creativity and my own voice with that consistently. To this day, I almost always refuse to use Google Maps because I like to navigate cities. Even when I'm visiting new ones, I will look up the directions and then I will do it. For some reason, it's just in my mind that I want the humanity of being able to manually do the task. And I think any engineer knows this, and anyone who's worked with tools. An invention of any tool will thus remove the manual skill that you had previously. And it's fine, most people don't know how to sew by hand or do this or that, or no longer write by hand even. But at some point, you can't really automate all of your life away. So I think it's kind of another maybe layer of the complexity of AI and the world of technology we are today, the human one. To what point is it acceptable to optimize all of your life and tasks? And then perhaps as an organization to make decisions about what and how should be optimized, that it minimizes the negative impacts on people. So again, it's being ethical in that sense as well. Am I kind of simply blindly saying that I don't need particular types of labor, or am I augmenting and actually enhancing how people work and what they can do that they couldn't do before?
Yeah, I think it's interesting to think about that way. I was going to say, so it's Lobotomation is the book that the poetry collection that you have out right now. So I'm just going to put a bit of a plug in there. I was going to say that I don't know if it's an MIE thing, but there is another author. We did a podcast with Eric Choi, who is also a sci-fi writer. He started that in his third year in mechanics. So I'm not sure if there's something that, in the secret sauce in mechanical building that sort of makes people writers.
You know what? It might be. But I think, like, for me, it's sort of the love of science and technology and creativity has always been there throughout my whole life. And picking industrial engineering, therefore, was not a mistake. But my earliest memory of kind of loving sci-fi and engineering, I was probably 6 years old, and my parents, who do not believe in censorship of what I watch, let me watch Terminator 2, which was like, quite lots going on in the film. But I fell in love with the idea of there's these robots, some of them are good, some of them are bad. So I guess we watched the movie on Saturday night, and Sunday morning, my poor parents are trying to sleep in, and they're getting awoken by a hammer going off in the office. And what was actually happening is I found my mom's old accounting calculator that looked like big and computer-y. And I was just
know where this is
destroying
headed.
it because I tried to find a microchip that would help me build a Terminator. So I think like ever since then, probably my passion began. I'm like, how do I tie together the worlds of sci-fi and perhaps also be able to be good at technology and engineering?
A little destructive influence there.
So I think that's what happens.
Yeah.
I think it's a little bit maybe people who are kind of into sci-fi and into maybe thinking through how technology relates to humans and how we are as kind of technological species that maybe draws us to engineering.
Let me wrap up with sort of what advice students are graduating into a very, we'll call it an uncertain future, right? A future that's in the midst of a huge transition. What's your advice to students? And then I'm going to frame this in the context of undergrad, grad, post-grad. Like you've gone through multiple phases, right? So what's your advice?
I think maybe a couple of advices. So first, don't worry if you think that your particular skill and specialties are not exactly where you think your next career might be. Trust the fact that engineering has given you a wonderful foundation to be able to be curious, to train yourself on new tools and new technologies, and to kind of take a hold of your career. So don't let it happen to you. And I think related second one is I would give an advice to not think too linearly about your career and to think in too harsh bounds between academia or professional environments. There's always an opportunity to come back. Places like U of T engineering are incredibly welcoming to alumni, incredibly welcoming to be able to go back, try postdoc, master's, just even talk to the faculty at any point. So I think that should give a student confidence that you're supported and you can experiment, and life is not linear itself. You can succeed in many things if you put your mind to it.
Right. So really take advantage of the opportunities as they show up.
100%.
Yeah.
So be a little bit opportunistic, be a lot strategic, and I think always kind of keep that systems thinking. What is the bigger picture? What can you do as an engineer? How can you take your responsibility and your engineering oath seriously? And how can you lead by example as well?
Perfect. Thank you, Jenya, for participating in the podcast. This has been an absolutely phenomenal and fun conversation.
Thank you so much. It was absolutely wonderful to talk today.
Thanks again for listening to Tell Me More, Coffee with Chris Yip. If you want to catch up on past episodes and to make sure you don't miss the next one, please subscribe. We're on Apple Podcasts, Spotify, and more. Just look for Coffee with Chris Yip. You can also check out at U of T Engineering on Facebook, Instagram, X, and LinkedIn for more stories about how our community is building a better world. And finally, if you'd be inspired to join us, we'd love to welcome you. If you're thinking of taking a degree or working with us on our research projects, you can find us online at engineering.utoronto.ca. Or you can visit our beautiful campus in Toronto, Ontario, Canada. I hope I can join you for coffee soon.